In this video, we are going to describe eddy currents. To get the most of this video, you will need to have a strong understanding of Faraday's law of electromagnetic induction and Lenz's law. Please make sure that you have a knowledge of both before you continue. Else, you may wish to revise the mini lessons again on these or read through your lecture notes before proceeding. So what are eddy currents? The normal current you know flows in wires. But currents can also flow in plates and conductors. When they do, they tend to make circular loops, like circular whirlpools in streams. These little circular loops of currents are known as eddy currents, and they are often used in braking systems. To illustrate how we can generate eddy currents in plates, let's consider a metal plate that is swung into a magnetic field. Now, let's break the motion up and first look at the case of the plate moving into the magnetic field. As the plate is moving into a magnetic field, the plate would experience an increasing magnetic flux. By Faraday's law, an EMF will be induced in the plate that will cause the induced current. So, how will this induced current flow? For that, we will need Lenz's law. Recall, by Lenz's law, the current induced should oppose this increase in flux. Hence, the induced current will flow in such a way to generate a magnetic field in opposite direction to the external field to oppose this increase in flux. Note, if we look at the direction of the field, the magnetic field is pointing out of the paper. Hence, we have a north pole in front of the plate and a south pole behind the plate. For the external field, we see that the field is pointing into the paper. Therefore, we have a south pole. Now, this south pole faces the south pole at the back of the plate. So what happens? Both the south poles will repel each other and a resistive force is produced. Now, can you try and get the direction of the eddy current for the plate when it is moving out? Pause the video and think through it. When ready, continue and check your answer. In this case, as the plate exits the field, it is moving away from the field and hence experiences a decreasing flux. By Faraday's law, an EMF will be induced in the plate which generates an induced current. By Lenz's law, the induced current will be set up to oppose this decrease in flux. Hence, the induced current will set up in this direction to generate a magnetic field in the same direction as the external field. Now, let's look at it in terms of the poles. Now, we see a north pole is now generated at the back of the plate facing the south pole that's generated by the external field. The induced current is therefore set up in such a way to attract the plate that is moving out, and again, it will slow the plate down. But what if we do not want eddy currents into our system? Are there ways to reduce it? Yes, one way is to cut slots into the plates, then the flow of the electrons are limited and smaller eddy currents are generated, and therefore there will be smaller resistive forces.